Hi, hello, good morning, everyone. We're just gonna wait like 5 minutes in order to start. We hope everybody is here, and just house cleaning stuff. We're gonna do the chat. The chat is available, and you can put your questions. The order, we're gonna have 2 speakers talking, and then the questions will be on the end. And we hope everybody can enjoy. We are admitting people here as they come. I did the mistake of putting, how can I say, the Zoom link on LinkedIn, and because of that, we need to have a little more careful on how to deal with the event. But other than that, thank you for everybody that comes so far. So one more. Okay. So for the people that are just joining, we are just waiting to 3 more minutes to start, and make yourself comfortable. And the idea here will be that we are doing like questions in the end, and thank you for everybody that is here. So 2 more minutes. Welcome everybody coming. As we are waiting 2 more minutes to start the event. The idea here on the event is gonna have 2 speakers, and then we're gonna do the questions at the end. And so we're about to start the event, and we hope everybody is here and eager to learn. So I guess thank you again for everybody that came. And I think we can start. Just thanks a lot for everybody that comes today. We are starting the event now. So my name is Adriana Freitas. I'm the director responsible for research projects in APWG. Today, I'm here to welcome you all on our DevSecOps workshop. The title is AI Vulnerabilities Identification and Fixing. We're going to be joined for experts from 2 very interesting Horizon projects, AI for Cyber and Lazarus. And we are here to discuss the technologies in cybersecurity, and also discover the solutions that are transforming the vulnerability identification and fixing, and also understanding the dilemmas that exist during a software code, the life cycle for software. We're going to gain insights on the latest strategies for enhancing cybersecurity defense, and we all hope to learn from the best in the field and elevate our cybersecurity knowledge. So today we have Ákos Milánkovich. He is the security analyst and R&D lead for Search Lab, and Constantinos Patsakis. associated professors at the University of Piraeus, and adjunct research at Athena Research Center, and myself. So to start, I'm gonna present Ákos Milánkovich. He finished his master's studies in Budapest universities as technology and economist in 2011 at the Faculty of Networks and Services, and he continued his doctoral studies in the topic of energy efficiency and wireless sensors networks. During and after his studies, he started working as a research engineer on various national and international projects and with industrial partners in the following domains: wireless sensors, agriculture, UIB, localization, and security. He's currently a security researcher at the Reseracher lab, and leading EU-funded researchers and penetration testing activities. I will now give the floor to Ákos, so he can start his presentation.
Thank you very much. Let me share my screen. All right. So welcome everyone. My name is Ákos Milánkovich. I represent the AI for Cyber project and Search Lab from Hungary in today's webinar. Let me give you a glimpse of the AI for Cyber project first. We started in September 2022, so we are just through half time of the project. It's a research and innovation action. The project coordinator is Technalia. We have 13 participant partners in the project, and the duration is 3 years. The AI for Cyber project aims to develop a framework using AI and big data technologies to improve cybersecurity. It recognizes the dual nature of AI, which can both defend against and be used for cyber attacks. The project will offer AI-powered software robustness and security testing services for small flow identification and automated code fixing. We'll also offer services to detect and analyze AI-powered attacks, improving system resilience. Additionally, AI for Cyber supports incident response, helping security operators optimize security protection, orchestration, continuously learn from system status and defense efficiency. Project ensures its technology respects fundamental rights and values, integrating explainability, fairness, and robustness into the components. Framework will be validated in 3 scenarios: detection and mitigation of AI-powered attacks against the energy sector, banking application adaptation to face AI-powered attacks, and hospital service resilience against advanced cyber-physical attacks. To make it work, the AI for Cyber project offers the following framework. This is an architectural diagram showing all the AI for Cyber tools. In the center, you can see the critical system we want to protect. And we want to do it by giving the actors that you can see on the left, like the security engineers, developers, security operators. We want to give them AI-enhanced tools. In the vertical, we see the 3 stages of preparedness, detection, and response that AI for Cyber covers. Horizontally, we see the development and operation time to work our tools in. And on top, we show you the Trust for AI component, which means that fairness and security of AI, along with explainability, is key in all of the components of AI for Cyber. So, as you can see, we concentrate on the operation part with most of our AI for Cyber tools. In terms of preparedness, we bring AI for SIM to simulate advanced AI-powered attacks. AI for CTI to gather cyber threat intelligence of adversarial AI. We also use AI for FIDS, for federated learning and enhanced anomaly detection. AI for triage, for root cause analysis and alert triaging. In the response domain, we have AI for SOAR, automatic orchestration and adaptation of combined responses, AI for ADAPT to autonomy and optimization of response adaptation, AI for DC for smart deception and honeypots, and AI for Collab for information sharing with privacy and confidentiality. And now we are concentrating in this webinar on the preparedness and development domains. We offer here two tools, AI for VALN for AI enhanced vulnerability identification, and AI for FIX, AI-driven self-testing and automatic error correction. Let me dive deeper first into the AI for VALN architecture. Once we have a project which we want to analyze, coming from GitHub or source code, this will be the target system. The AI for VALN first employs a Java analyzer component, which will do static source code analysis, then initiate the control flow builder, which will generate abstract semantic graphs with the control flow. And symbolic execution engine will create a symbolic tree, which will be fed to a vulnerability hunter application, which will do the vulnerability detection. And we will feed the identified vulnerabilities to our next component, the AI for FIX component, which also starts with analyzing project repository. It will build what we call a software evolution. We concentrate on the changes between the commits of all of the commits of a repository, and we build up models from the extracted features. We build a generic and custom model that I will talk about later. And these models will also get information from the AI for Vuln component with the identified vulnerability locations. And the model output will be fix and test generation done with automated robustness improvements in the meantime. And let me show you how step by step it works. First, we build a data set of open source repositories, commit by commit. We learn the typical fixes for the typical bugs that are present in any source code. Then we analyze the actual repository that we want to improve. We learn its characteristics to make our fix and test generation more fitting and more customized to the actual repository that we are working on. Then we obtain the potential vulnerability locations coming from symbolic execution module from AI for Vuln, and we add the general robustness improvements, the fixes that we generate first. Then we generate our fixes for the vulnerabilities. We employ retrieval augmented generation here as well. Then we do a quick build test because all the generated fixes, of course, need to pass. Then we are generating new tests to incorporate the changes or react to the changes that we introduce by the patches. Then we do patch prioritization. And since we believe that in the development era. We need the human in the loop. We show this to the developers using their own IDE. We can integrate our tool as a plugin. And after showing the generated fixes, the developer is able to select which fix they prefer. And with their feedback, we expand our data set to make more customized and more fitting fixes in the future. The AI for Fix tool developed by Search Lab in the project is currently a work in progress, and here is the evolution or the steps that we are actually implemented. We first worked on dataset collection, and of course this is an ongoing process. We want to refine it. We collected bug fix pairs for software evolution with a tool that we built, purposely built for this, called the Miner tool. Then we made Jira issues for commit classification and built a Jira miner for that, because we want to help the AI for Vuln component to optimize the symbolic execution tree traversal by selecting the security relevant features of the code and analyzing those parts deeper. Then we built proof of concept solutions for robustness improvement based on static analysis tool outputs. And we built fix generation module, which generates multiple fixes, which need to be tested first for compilation, then for functionality. We test whether the functionality remained by executing the tests of the project originally present in the repository. But additionally, since we may introduce changes to the code, we add new tests, we generate new tests. And it is also based on the existing tests of the project that we learned in the previous model generation step. First, we use online large language model services to bring the fixed generation alive. And now we are researching local execution solutions. And we have a public deliverable which summarizes our results. It's the 3.1 of the project. You can check it in the project website. Now it's time for a demo. First, I will show you how AI for Vuln is executed, and it gathers potential vulnerabilities. Then they will be handed over for fix generation to AI for Fix, which will generate the patches. The developer will select those patches. Also, we'll generate the tests, and we can get back to the development cycle by adding these patches back to the repository. Okay, I will start the demos.
AI for Vuln is a static source analyzer that can detect runtime errors in Java software without executing it. It analyzes the source code and builds an abstract semantic graph that stores all information about the analyzed code. Next, it creates the corresponding control flow graph and simulates the execution of the program on the possible execution paths. Execution is started from every method of the program. It reports the vulnerabilities that were found on the execution paths. The output informs the user about the nature of the problem and where its location in the code. For example, there is a negative array size problem in the code at line 69. Additionally, we can see the trace as well, which shows the user an execution path that leads to the negative array size.
Building on the outputs of AI for Vuln, the AI for Fix tool offers a UI in the form of a VS Code plugin where the developers can interact with the generated fixes. After installing the plugin, the settings should be tailored to the repository. Next, after starting the analysis, the fixes are generated and the results appear shortly in the analysis output panel and the integrated problems panel grouped by issue types. We see two issues, null dereference and negative array size, in this demo. The developer can dive into the detected issues and view the offered potential fixes marked inline in the original source code as well by underlining. Clicking the bulb icon, we can view the diff of the patches directly. For the issue with negative array size, AI4 fix generated 3 potential patches in the background with the help of large language models, which are all syntactically correct and validated solutions. Once the appropriate fix is selected, the user can mark it applied with a feedback field. Then the selected fix will be patching the original code. Tests can also be generated for the applied patches to ensure proper execution. Generated tests are blending into the already available list of test cases and the test framework used by the project. All the tests were executed successfully.
Okay,
Building on the outputs of AI4 Vuln.
and now thank you very much for your attention.
Thank you, Ákos. And now we're gonna do questions and answers in the end. Just to let me just check if there is anybody else that came on to the event. I think there is like people in the waiting room here. It's just a second. Let me just admit everyone. So thanks again. Sorry for the people that arrive a little late. You are at the a DevSecOps webinar. Today we're doing AI vulnerabilities identification. We just had the talk from Ákos from AI for Cyber. And now I would like to introduce Kostas. So Constantinos Patsakis is currently an associate professor at the University of Piraeus and an adjunct researcher at Athena Research and Innovation Center. His first degree is mathematics for the University of Athens, Greece, and his master's is in information security at the University of London. He holds a PhD in cybersecurity from the University of Piraeus, and his main areas of research includes cryptography, security, privacy, and cybercrime. In the past, he had worked as researchers at the UNESCO chair in data privacy at the Rovira and Virgil universities in Spain, and at the Trinity College in Dublin, and at the Luxembourg Institute of Science and Technology. No further ado, I would pass the host to Kostas. Kostas, please mute yourself and put the video on.
I think that everything works now, right?
Yes, yes.
Okay, let me share my screen and off we go. So many thanks for the introductions. Okay, okay. So our project is called Lazarus, which is an abbreviation for Platform for Analysis of Resilient and Secure Software. So currently our goal is to design, develop, test, and validate a new intelligent framework for the development of secure applications. So I'd like to share some statistics in order to understand what the problem is, because many times we are discussing about vulnerabilities, and I think that we have several problems here. So practically this is more or less the CVEs by year. As you can see the statistics are continuously growing. However, there is something strange happening more or less here, which is 2017. So practically we have a huge gap between 2016 and 2017. Either the developers became more stupid and started doing crazy stuff on their code and having more vulnerabilities, or they somehow started reporting what the issues are. This was triggered by both GDPR here in Europe and the Presidential Policy Directive 41 in the States. So these are the two drivers that are currently leading people to report the vulnerabilities and publicly disclose them. Nevertheless, we have to understand what we're trying to do with Lazarus. So practically, we are not trying to create a new tool, but a toolkit in order to adapt the existing pipelines that people are using for software development life cycles. Practically, what we want to do is to allow organizations to pick and choose the tools that they deem appropriate for their pipelines, trying to come up with a new to push, let's say, our own agenda into SMEs who have already existing pipelines, and they have to reschedule everything that they are doing in order to user approach is not something that it's easy to consider realizable. So what we want to do is to allow them to more or less easily shift from what they have, which is a DevOps pipeline, to something which is integrating security and converting it to something that we call DevSecOps. And moreover, we have to understand that when it comes to vulnerabilities, most solutions are very static, and this is something that we are going to discuss afterwards. Another, to this end, this is something which is very important for us, is to understand how secure are the applications that we are deploying when they are running, and not only having access to the source code. What we want to allow to developers and software houses is to more or less have their own word on where the tests are performed. We understand that a software house might be reluctant in order to share their code, their tools, or whatever, or their actual intellectual property with people, meaning that they might not want to shift everything to the cloud. So there's also the case of running everything locally on their own premises, so that they can control what information goes in and what goes out. And another question for me, which is part of the research that we are doing, is whether you have stress tested your pipelines. The case is that there might be vulnerabilities that you haven't understood, or how people can bypass these existing pipelines. So this is more or less the outline of our consortium. We have 10 partners from 8 different member states. We have people from the research part, research organizations and universities. and we also have practitioners from different sectors. Nevertheless, all of them deploying software and having, let's say, the problems on their own hands. So, as I said before, the main motivation is to shift from DevOps to DevSecOps in, let's say, a very seamless way. So for me, a very important part when we were discussing the project and when we were streamlining the research, and has to do with how we understand threats and where they come from. I think that the recent case of XZ utils and the vulnerability / backdoor that was integrated in the latest version is a very fine example of how we base our projects in different libraries. We have different dependencies which can be backdoored, and we can have different kind of adversaries. So here we have probably an advanced persistent threat group that was persistently and for many years trying to backdoor the pipeline, the project XZ utils. It showed how the human factor was tricked in order not to perform some tests, and how many existing security pipelines actually missed this kind of vulnerabilities, and everyone was integrating this, and actually it was deployed. Showcasing that existing SaaS tools, either because of the human factor or because of the trust that we have, can be easily exploited. So practically what we want to do with Lazarus is to automate security testing, provide legal framework compliance, allow organizations to assess their exposures to risk, to perform threat modeling, and detect and assess specific vulnerabilities. Moreover, there is a part that has to do with security and training and awareness. So if we see it as a pyramid, we start from automated vulnerability discovery, and we build on top of it in order to realize DevSecOps, provide resilience and self-healing. This is something that our colleagues from AI for Cyber also are working on. And this is more or less a complementarity of the two projects and showcases why we're here. Through this, we want to achieve NIS and GDPR compliance and provide information intelligence sharing so that the proper stakeholders are informed of what is the exposure and probably countermeasures. To validate what we are building, we are going to have some use cases. One of them is focused on marketing technologies. Another one has to do with enterprise software. The other one is trying to secure a content management system, and another one is trying to secure IoT devices. So the higher level overview of what we're trying to do is that we are creating a sandbox in order to execute the executable, the solution that it's being deployed by the organization, so that we can understand both during the testing and the during development whether there are security issues. Nevertheless, since we are targeting the software housings, we also have access to the back, which means the code. So the goal here is to go to the to the code repositories in order to collect the code and understand whether there are vulnerabilities. So practically, since we have the sandbox, if we are able to understand that there is an attack or we understand that there is a vulnerability, that it's being exploited, the monitoring node is going to send to trigger an alert, and possibly if this is enabled to perform the an automated patch, so that the software solution has an automated way in order to, let's say, block specific packets, block specific requests, etc. These are recorded in reports which are sent to the DevOps to DevSecOps team and provided to information sharing platform, so that, for example, Search Isaacs can see the exposure. Currently, we are in the alpha version, which, apart from the user interface, contains 4 main modules. One has to do about secret scanning. The other one is about the software bills of materials, and 2 more, which one of them has to do with detecting and patching software source code vulnerabilities, and the final one has to do with automating the detection of SQL injection vulnerabilities. So the interface is more easily to see here of a project that we have, let's say, configured in order to test during our testing of the platform. About the secret scanning, I have to say that this is far too often missed part in many solutions. When we say secrets, we consider credentials, API tokens, but practically most solutions are trying to use high entropy to detect high entropy strings, or try to use regular expressions, missing things that are very often used by developers who might also use different ways to express things, and may hide this in different files. Currently, we have created a dedicated module to do that. It's using a specific technologies that have been tested and verified quite, let's say, strictly scientifically. Currently, apart from just saying that something we have found a secret, we are also understand the context, whether this is credentials for databases, for mails, for automations, web services. Here I have an example, for example, for a case of an open source project. Someone, as you can see, has created the code and practically has in comments the username and password that it's used. It also has the link to a public interface for a database. Our tool is able to extract this in a JSON file so that you can use it in your pipelines. And apart from saying that what I have found, so practically you can see the username, the classification that it's for a database, and everything that it's there. It works quite efficiently, and it can be deployed on a Docker so that you can deploy it in your existing pipelines. Similarly, we have another module which is about the software bill of materials. So currently what it does is it's trying to automatically scan the components in the SBOM against a non-vulnerability database, so that you can see, for example, the associated CVEs. This is practically what we are doing right now in the alpha version. And this currently the availability for configurations it's something that is going to be provided in the beta version. So what you can see is an output that provides you with the score of the vulnerability, how severe this vulnerability is, a small description, how many elements have the vulnerabilities, so that you can understand to what you are exposed to. Apart from that, we have two models that have to do with the detection and patching of the code. The first one uses CodeBird in order to, let's say, have a wide understanding of different programming languages, and will provide you with a binary classification of whether something is vulnerable or secure. Nevertheless, we also have another model which is based on code T5 in order to, apart from saying that something is vulnerable, provide you with a solution so that you can quickly integrate it in your project. So the pipeline is very straightforward of how this is going to work, and we're trying to, let's say, provide a seamless integration for the developers in order to use it. Practically, this is something that it was also shown by Ákos before, but they have a different approach on that. So I think that the use case is very similar, and we also have another module which automates the detection of SQL injection vulnerabilities with existing open source tools, so that people, I mean developers, do not have to go through the struggle of learning new tools or identifying individually what they have to do, but let's say understanding in a homogeneous way, and providing the REST interface so that everything can be tested automatically. So finishing the presentation, the conclusions are that we are strongly focused on the transition of DevOps to DevSecOps. We want to exploit AI firstly to detect vulnerabilities, but nevertheless we see it also as the main driver to also provide solutions. We understand that the vulnerabilities is not something which will always be found statically, meaning only on the code. And this is why we're also focusing on the part that has to do with the dynamic part and how things are actually executed and what comes out of them. We want to allow people to select what they deem appropriate for their existing pipelines, and not redesign everything just for what we are doing. And invite everyone to stay tuned because we are going to have more updates quite soon. Thank you.
Thank you, Kostas. And it's two amazing presentations. I would like to state again that if there is like any questions from the audience, it will be better. It will be great if you guys could use the chat for that. I do have some questions here that I could start, and maybe my first question, and I do need to give both speakers the floor to talk. Just a second, let me do that. As my first question will be to Ákos, and maybe more in the sense of like, you know, what sort of roles does he think on that privacy plays in the AI detected vulnerabilities, and if he could speak a little more related to that. Let me just I just think that is here. Just a second. I'm having my own trouble with my own interface here. Is always like that. Let me just give the floor to Ákos to respond. And as usual, you're here. Just a second. Ákos, please, sorry about that.
Okay, thank you. So in AI for Cyber, we handle privacy seriously. We audit the models and the tools in a dedicated work package. And for code fixing and static analysis, we also use local large language models, meaning that no source code is uploaded to any server to make the code generation happen. This is how we protect intellectual property of the organizations. For example, we have banking, healthcare, energy sector use cases where these are really important aspects.
Okay, thank you. I think my second question goes to Kostas. Kostas, how do you think there is a big thing on generative AI and LLMs and all that? How you think they can facilitate secure coding practices, and how you think they could be applied?
Okay, thank you. So practically everyone is looking now at AI and machine learning in order to provide solutions. And LLMs have become, let's say, the answer to almost everything. Nevertheless, I think that we have to understand that we have a very specific pipeline which exists in many projects, and this is garbage in, garbage out. Sometimes we have to understand that when you feed the project with your input with garbage, what will go out, it will also be garbage. Practically, when you give a whole repository with code from C++, from Python or whatever, and you expect someone to understand what is secure and what is not, it's not going to work. Most people and most commits that you will find on GitHub or any other code repositories contain many errors, or either logical or security. Nevertheless, many of the LLMs have been trained with such code. So if we just expect that the LLM will simply, because it has seen many repositories, it will understand what is secure and what is not, it's not going to work. We have done several tests and we have found that in many cases, LLMs can find vulnerabilities, Nevertheless, in some cases, it's just hallucination, and they're just reporting a vulnerability just because you asked for it. So if you ask it, okay, what kind of vulnerability this is, you will get practically something quite random. I see Ákos nodding, so I think that we completely agree here. Nevertheless, the amount of vulnerabilities that we can have, I mean, in order for properly training an LLM, is something which is very crucial. And we have found that there are many discrepancies depending on how the LLM is trained, how big is the data set, and even if you run specific tests and you have excellent results with an LLM, if you simply play with the data set, then you might find that, well, you don't find anything. So I understand that the ways from LLMs, nevertheless, I think that we have a long way in order to see this actually working. We need better data sets, we need more access to what is happening behind, especially for, let's say, non-local LLMs, and trying to understand whether the quality of the data sets that they have been trained in order to fix them appropriately. Sorry for the long discussion, but the LLMs is a big topic right now, very hot.
No. We all understand that, and so I do have one final questions, and I hope if anybody has a question, please use the chat. I think my final question is for Ákos, and maybe it's like how you think you can manage the possibility of false positive and false negatives in an AI-based vulnerability detection, and how you have been treating that.
Okay, so current approach for source code analysis is using static and dynamic analyzers. Static analyzers give you a whole bunch of warnings that the developers need to handle, and this is practically impossible for them with the huge amount of warnings. There are many false positives inside, and of course undetected things as well. And here comes the importance of neural networks, which can make deeper analysis compared to simple static checks. We need to take a look into the logic, and using this new capability emerged from large language models, we're able to see deeper in the code, understand the code deeper, and generate the fixes based on that deeper knowledge. So in that sense, I think LLMs have much better potential in analyzing and correcting deeper or not trivial, statically trivial type of warnings or code robustness problems. On the other hand, even if we just filter and rank the outputs of static analyzers, we can significantly reduce the load that is required for the developers to improve the code base. So basically that's the...
Okay. Now, thanks a lot. And again, I would like to thank you, everybody that came and spoke, like, you know, and thank you for AI for Cyber team to even help me organize this, and to Costas and the team from Lazarus that helped me into this. So just to say that this is our first workshop. We are intended to do more of this and bring other projects and bring ideas together, because we do think that mixing and understanding what the rest of the people does, and is a learning pot for everyone. I just post on the chat our newsletter. Here we have listed like, where we're gonna be speaking. And we also will put on the newsletter the next events we have. We hope to see you on our next event will be in Barcelona. And we also plan to do more workshops like that. And I'll keep everybody posted. And thank you a lot for everybody that comes. Any final words you guys want to chat? Kostas?
And just a big thank you to everyone for joining, and keep in touch, because I think that we are going to have more news quite soon.
For sure. Okay. Thank you,
Thank
Ákos.
you, everyone.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.